All right, the last thing we're going to look at when solving quadratic equations is something called the quadratic formula. So sometimes when we have quadratics in standard form, they can't factor. We saw some of those examples in the last lesson. But we saw that sometimes that can mean there's no solutions, right? Like on the left side here, we have no x-intercepts. But sometimes that can just mean that our x-intercepts are some sort of irrational number. They're not a nice value, right? They're not something that we can factor. We don't necessarily know that negative 1.54 times positive 4.54 multiplies to 6, something like that. Right? So we have a formula that can solve any quadratic formula, all cases, factorable or not, solution or not. The quadratic formula is going to help us figure that out. And it's this big formula here. X equals, right, because our solutions are x values, negative b plus or minus b squared minus 4ac, all under a radical, and then all divided by 2a. So what this means is I'm taking those a's, b's, and c's out of our standard form. So ax squared plus bx plus c, those are those a's, b's, and c's that I'm going to fill in here. Right? A shows up in a couple of places. Whoops. B shows up in a couple of places. And then C also shows up here as well. So I'm going to plug all those in. It also has, if you notice here, this little plus or minus sign. So what this means is I'm going to do it 2 separate times. Plus or minus means once where I'm adding that negative b and then the radical, and then once where I'm subtracting, right? That's how we can get 2 separate solutions from using one formula one time. There's an important part of this formula, and it's called the discriminant. It's that value, that portion of the equation underneath the square root. It's that b squared minus 4ac. And why is this important? Well, through our radicals unit, we learned that there's specific things we can and can't do with radicals. Right? We can't square root radicals. So this part, the discriminant, is going to help us tell us the number of solutions. So if we have one answer, if we have 2 answers, or if we have no answers. So if our discriminant is negative, so if b squared minus 4ac, when I plug in a, b, and c, if that turns out to be a negative value, that means I have no solutions, right? Or what we also call root zeros, there's no x-intercepts. It looks like that graph on the top left. And that's because I can't square root a negative number, so I can't proceed any further with solving the quadratic formula. If I have a discriminant value of 0, then I have one solution, because that means that in my equation, when I get to that plus minus, I'm going to add 0 to get my first solution. I'm going to subtract 0 to get my second solution, but that's the same number. Let me do this in a color that we can see. All right. So if I have a discriminant value of 0, that means I'm getting, essentially I get the same answer twice, so I only have one solution. And then if my discriminant is a positive number, right, I can square root any positive number. Whatever that number is, I'm going to solve this twice, once where I add that number, once where I subtract that number, and that gives me 2 separate solutions, 2 values. So if my discriminant is greater than 0, I have 2 solutions. So let's look at these quadratics, and first let's just find how many solutions we have. We're not going to find out what the solutions are just yet. So for all of these, just like when we were factoring, I need to start in standard form so that I have an a value. In this case, my a value is 2. I have a b value, in this case positive 5. And I have a c value, in this case negative 3. Right? Always coming back from that part where I have ax squared plus bx plus c. Right? A is in front of the x squared, b is in front of the x, c is the constant, keeping whatever sign it has attached to it. So when we talk about a discriminant, right, we are going to just worry about that b squared minus 4ac part. So b squared minus 4ac. The work is done up there above for us, but let's just look at this. B squared, so b was 5, I'm squaring that, minus, the 4 is part of the equation. A was positive 2, c was negative 3. So I'm going to work on this in two parts, kind of. I'm going to do the 5 squared, so I get 25. And then I'm going to multiply these last three things together. I'm going to treat this like a negative 4. So negative 4 times positive 2 is negative 8. And then negative 8 times negative 3 is going to be positive 24. Right? The trickiest part is keeping an eye on the signs of that second chunk. Right? Think about that as a negative 4. If you're multiplying negatives by negatives, we're going to get a positive answer. So we see, just like the question already told us, the discriminant has a value of 49. Because our discriminant, b squared minus 4ac, had a value greater than 0, right? Because 49 is larger than 0, I get two solutions. Right? And we can see that on the sketch of the graph. I have one solution here on the left side, and I have one solution here on the right side. Right. If I wanted to know what those solutions are, we'd do the whole quadratic formula, and we'll get there. Let's do one more of just determining solutions. So pull out our a value of 1, b is 4, and c is 4. So I want to check my discriminant, b squared minus 4ac. And I want to say, is this bigger than 0, equal to 0, or less than 0? Those are my only three options. So I plug in my values. B is 4 minus 4 times 1 times 4. Right? We got our a value in here. We got our b value out front. We got our c value in here. And then that 4 out front of that second term is part of the equation, right? It's always a times 4. And this whole formula, this whole idea comes from the idea of going from standard form to vertex form, but that's not a process we're going to cover in this course. So piece by piece, I'm going to solve this left side. 4 squared gives me a 16. And then I'm doing negative 4 times 1 times 4. Overall, this thing is still negative. Right? 4 times 1 is 4, times negative 4 is negative 16. If you want to call this lowercase d, just to say you're talking about the discriminant, you can do that. And so in this case, my discriminant is 0. What that tells me is I have one solution. And we see on the graph, right, we only have one x-intercept at negative 2, 0. All right, so it just tells us, again, the discriminant tells us the frequency, the number of solutions. It doesn't tell us where those solutions are. We have to use the whole formula for that. So let's practice some of that. You can give example 3 a try on your own. You're going to notice that your discriminant is a negative number. So discriminant is less than 0. So you get no solutions. So let's look at solving using the quadratic formula. So again, we need a, b, and c first. It would always be helpful to write these out. So a is positive 2, b is 5, and c is negative 3. So in this formula, first thing I'm just going to do is put in all those numbers. So I have negative b. B was positive 5. So I just end up with a negative 5. I would recommend putting all these things in brackets so that you're not missing anything. You're not losing negatives that you have or losing negatives that are already there. Plus or minus the square root of 5 squared minus 4 times 2 times negative 3, all divided by 2 times 2. So x equals negative times 5, right? We get a negative 5 plus or minus 25 is 5 squared plus, right, because I had negative times a negative, I had this negative in front of the 4. times the -3, I get a positive 24. And we've actually solved for this discriminant already in one of the previous examples, over 4. I'm going to keep simplifying that radicand first, right? If you want to do this discriminant in one step, 49 over 4. And at this point, we want to evaluate. So I have two options. And I have to do both. It's not a one or the other situation. I know we say plus or minus, but I need to perform both. I need to do one case where my first x value, my first solution, is -5 plus root 49 over 4. And then I need to do another situation where I have a second solution, right? Because I had a positive discriminant at -5 minus root 49 divided by 4. So I solve these. Right? If you have a graphing calculator, you can create a fraction. You can go alpha f1, and it gives you a fraction. If you don't have that feature, you can just use brackets. So it's -5. I'm going to do plus the square root of 49 divided by 4. And it tells me the answer is 1/2. You can also do this piece by piece. You might recognize that the square root of 49 is just 7. So you're doing -5 plus 7, and then dividing that answer by 4. Right? Either way, you're getting 1/2. You're getting 0.5 for our first solution. X equals 0.5. You might want to call it x1, something like that, just to indicate it's one of two solutions. And our second one, so I'm doing -5, and now it's minus root 49, so you might see that as -7 divided by 4. My second solution is -3. And if I go back quickly, I look at what the graph of this looked like, 2x squared plus 5x minus 3. Notice I have a solution at -3. I have an x-intercept at -3, and I have an x-intercept at positive 0.5. So I can find those now in 3 different ways. With this one, because it is factorable, I can find it by graphing, right? I'm looking at the graph right now. I can find it by factoring, because technically I can factor this one. Not all of them are factorable. And I can find it using the quadratic formula. So it's up to you to choose which method you think is going to be best for you. So we'll try one more, and then I'll leave the rest of the examples for you. So first thing, pull out A, B, and C. A is 1, B is -2, C is -1. Make sure you're just taking the coefficients. There shouldn't be any x's showing up anywhere here, other than the x equals. So our formula is -b squared, -b, which in this case, b is -2. I still have to negate that. There's still the negative out front. So it kind of gives me a double negative effect. B squared, and again, I'm going to put it in brackets just to make sure I'm still including that negative, -2, minus 4 times A, which is +1, times C, which is -1, all divided by 2 times A. So x equals, this is going to become a +2 out front, right, because I'm negating that -2. Plus or minus b squared, so -2 squared is +4, minus 4 times 1 times -1. This double negative here means that I'm actually adding, just a 4 here, because I had 4 times 1 times 1, all divided by 2. Simplifying this a bit, I get 2 plus or minus the square root of 8 over 2. I'm going to go ahead and solve that. I'm going to go 2 plus the square root of 8 and divide that answer by 2. So my first option is 2.41. whoops, to 0.41. So that was the situation where we did the positive operation. We plussed. We added. Now we'll subtract for the second situation. I'm going to do 2 minus root 8. And then divide by 2, right? And only that plus or minus sign changes. So I get negative 0.41. So those would be where I have 2 x-intercepts on this graph. So I want you to give the other ones a try, check your work at the end, and let me know if you have any questions.